Hi students, this is Alex here. In this video, we are going to find the Fourier series of periodicity 2L for the given function f of x, and we are also going to deduce the sum of the given series. In the first part, we are going to write formula for Fourier series, which is f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos n pi x by L plus sigma n equal to 1 to infinity bn sin n pi x by L. Now to find a naught, we use 1 by L integral 0 to 2L f of x dx, but here f of x is made up of two parts, so we take the first part from integral 0 to L. F of x is L minus x dx, and the second part is 1 by L integral L to 2L, and f of x is 0. So the second part is completely 0. We have only the first part, so 1 by L, and L minus x integration is Lx minus x square by 2. And we have limit from 0 to L. So this is 1 by L. When I put L for x, first term is L square, and this is L square by 2. When I use the lower limit, everything becomes 0. So finally, we get 1 by L, and this by taking LCM 2L square minus L square, and this will be 1 by L into L square by 2. After cancelling this, we get L by 2. So finally, we got the a naught, which is L by 2. So this we keep it separately. Now second part, we are going to find an, and an formula is 1 by L integral 0 to 2L f of x dx into f of x into cos n pi x by L dx. Now again, this is 1 by L integral 0 to L minus x into cos n pi x by L dx, and this is 1 by L integral L to 2L and function value is 0 into cos n pi x by L dx. Now this is 1 by L integral 0 to L minus x into cos n pi x by L dx, and second part is completely 0 because f of x is 0. Now to continue this integration, we are going to use Bernoulli's formula, where one term is u, another term is v. The formula is u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus dot dot dot. Now an becomes 1 by L u v1, u is L minus x, v1 is integration of v, which is sin n pi x by L minus u dash. U dash is derivative of this L minus x, that will be minus 1 because L is 0 and minus x is minus 1. And v2 is the integration of this v1, so which is minus cos n pi. Actually, here when we integrate, we have to divide by n pi by L also. So here it is minus cos n pi x by L by n pi by L, but already there is n pi by L, so it will be n pi by L whole square, and u double dash will be 0, so the third term no need to write, and we have our limit from 0 to L. Now when I use the upper limit, the first term already we have L minus L, so it becomes 0, and second term there are 3 minus, so it will become 1 minus, and when I put L here, LL gets cancelled. We have only cos n pi, and cos n pi is minus 1 whole power n, and we have n pi by L whole square minus, when I use the lower limit, because of this sign, first term is 0 and this is 3 minuses are there, so its product is single minus, and cos 0 it will become, so it is 1, and we have n pi by L whole square. So after this we take this one as 1 by L, and here we keep this minus, then minus 1 whole power n phi n square pi square by L square. So that L square I can take to the numerator, and this minus it will become plus when I take it inside. So 1 by n square pi square into L square. Now totally we can take the common L square by n square pi square. After that this term becomes 1, and this is a negative term, so I am writing it as a second term. So minus 1 whole power n with a minus n outside. Now this is our an, but if n is odd, it means minus 1 whole power n, that is minus 1 power odd number will be minus 1. So when I use it here, an becomes, we can also cancel this, L by n square pi square and 1 minus of minus 1. So totally this is 2. So we get 2L by n square pi square. But if I take, if n is even, then what happens is minus 1 whole power n, that is minus 1 whole power even number will be 1. So when I use that here, 1 minus 1 it will become 0. So an becomes 0. So we got the value of an when it is only odd. So we shall keep that as it is. Now we are going to find bn. For bn, again the formula is 1 by L integral 0 to 2L f of x sin n pi x by L dx. We are going to split this into two parts. That is 1 by L integral 0 to L, f of x is L minus x. Then we have sin n pi x by L dx plus again 1 by L integral L to 2L, f of x is 0 into sin n pi x by L dx. Second part is anyway 0. We are going to use Bernoulli's formula. This is u and this is v. Integral uv dx will be u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus dot dot dot. So using this formula, we are going to continue finding BL, which is 1 by L outside, u v1. U is this, v1 is integration of sin n pi x by L, which is minus cos n pi x by L by n pi by L. Then minus u dash, which is the derivative of u, which is minus 1, and this integration of this v1 gives v2. So minus sin n pi x by L by n pi by L whole square, because already there is n pi by L and we have to divide also. Then finally we take the limit from 0 to L. When I use L, first term is L minus L, so it is 0. Second term, after putting L here, we get sin n pi. After putting L here, LL gets cancelled, sin n pi, which is 0. So totally the upper limit value is 0. When I come to the lower limit, I have to put 0. When I put 0 here, we left with only L, and cos of 0 is 1, but there is a minus sign here. Along with it, we have n pi by L, and second term will be 0 because sin 0 is 0. So close the bracket. Then finally we have 1 by L. into this minus product will become plus. So L by N pi, and this denominator L can be taken to the numerator. So after cancelling this, we have L by N pi. Now substituting this in the Fourier series formula, our f of x becomes a naught by 2. The value of a naught which we got here is L by 2. So L by 2 becomes L by 4 plus summation n is equal to, for a n that exists only if it is odd, and its value when n is odd, its value is 2l by n square pi square. So 2l by n square pi square cos n pi x by l when n is odd till infinity, and again summation n is equal to 1 to infinity, bn is l by n pi sin n pi x by l. So we got the formula, but certain terms can be taken outside the summation. So f of x is l by 4. Here we can take 2l by pi square outside the summation, because the summation is applicable for the n term. So summation when n is odd till infinity, we have cos n pi x by l by n square, and here it is l by pi common, summation n equal to 1 to infinity sin n pi x by l by n. Thus we got the first part of the question, where we found the expansion for the Fourier series for the given function f of x. Now as a second part, we have to find the value of the series. The first series is 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 dot dot dot, and we have to prove it is pi by 4. So from this f of x, we have to take a suitable value, and since it is not having the square values in the denominator, here it is n square and here it is n. So we have to take a suitable value for x. So I'm going to take x is equal to L by 2, because cos n pi, in place of this x, if I put L by 2 and there is L, we can cancel this. So cos n pi by 2 will become 0, so this term will disappear. Whereas sin n pi L by 2, and there is another L. So this sin n pi by 2 will be alternatively 1 minus 1, 1 minus 1 dot dot dot. When n is 1, it is sin pi by 2, which is 1. When n is 2, and it will be 0. And when n is 3, it is minus 1. So basically to say, there is a 0 term also. That's why we are getting the odd number series, as we noticed in this term. So there are no even terms. So this will be 1. Then when I put n as 2, it is 0, because sin 2 pi is 0. When I put 3, it is minus 1. Then 4 again 0. So like this it goes. So the correct value for first subdivision, the x is L by 2. So our function f of x, we have L minus x in the interval 0 to L. So when I choose L by 2, we have L minus x. So f of L by 2, f of L by 2 will be L minus x. So L minus L by 2, that gives L by 2. So we are going to use all this. So now for f of x, I put L by 2, and this is L by 4, and this sin term exists and cos term does not come because it is 0. So 0, and now L by pi summation n equal to 1 to infinity sin n pi by L into L by 2 and by n. We can cancel this. So we have L by 2 equal to L by 4 plus L by pi, and we open the summation. So sine 1 pi by 2 plus sine 2 pi by 2. We have to write this also by 1. This is 2. When I put 3, sine 3 pi by 2 by 3. When I take 4, it is sine 4 pi by 2 by 4. Then sine 5 pi by 2 by 5. Like this, keep going till infinity. Now we shall take this L by 4 to the other side. L by 2 minus L by 4 equal to L by pi. This is 1 by 1, and sine 2 gets cancelled, so sine pi, which is 0, sine 3 pi by 2, which is minus 1, so minus 1 by 3, this becomes sine 2 pi, which is 0, then sine 5 by 2 will become 1, so 1 by 5, so like this we get the series till infinity. Then let's check our question. So 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 dot dot dot. So we got it. Further terms, if you write, I will also get the minus 1 by 7. Now we take LCM here. LCM is 4. So 2L minus L equal to L by pi, and we have 1 by 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus dot 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 till infinity. And this is L by 4. And this L by 4 we shall take to the other side as product, and by taking its reciprocal. So pi by L. So when I carry here, pi goes to the numerator, L goes to the denominator. And we get as usual 1 minus 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus dot 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 infinity. So finally, after cancelling this, we get 1 by 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus dot 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 till infinity, which is pi by 4. So we got the summation value here. The value of this series is pi by 4. Let's cross check again. So they gave the series 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 dot 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 is pi by 4. So we got it here. To get the second proof, again we have to choose another value of x. So the second proof summation I have copied here. We notice here it is 1 square, 3 square, 5 square and 7 square in the denominator. It is going in terms of odd. So we have to use this summation by taking the suitable value for x, and this term should not come because it is having only n in the denominator, but all the terms what we have is the square form, n square form, that too odd number square. So let's take x as 0. So f of x at x equal to 0, since the 0 is the extreme value of the interval 0, 2l, we find the function value by taking f of 0 plus f of 2l whole divided by 2. And f of 0, we have to choose the first L minus x. So L minus x is 0 and f of 2l is already 0, then whole divided by 0, we are getting it as L by 2. So when I use that here for f of x, I have to substitute L by 2. So I write it here. So for f of x, it is L by 2. First term is L by 4 plus 2L by pi square into summation n is equal to odd till infinity cos n pi x by L. When I put x as 0, the total value is 1. So we have only 1 by n square, and the last term, since it is sine, when I put 0 for x, the entire term is 0. So this is L by 2 minus L by 4. I take this L by 4 to the other side, and here it is 2L by pi square we're going to expand the summation. We have to keep placing the odd value for n. So 1 by n square. The next odd is 3. So 1 by 3 square. Next is 5. So 1 by 5 square. Next is 7 plus 1 by 7 square plus dot 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 till infinity. So we're going to take LCM for this. LCM is 4 here, and this is 2L minus L equal to 2L by pi square, and we have the summation 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus 1 by 7 square plus dot 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 till infinity. So this is L by 4, and this 2L by pi square can be taken to the other side by taking it as a reciprocal, pi square by 2L, which is equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus dot 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 till infinity. So finally we can cancel this L and L. So now 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus dot 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 till infinity is pi square by 8. Thus we got the second part of the summation series. So the question is here, 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus 1 by 7 square is equal to pi square by 8. We just got it.